Okay. Hi guys. Start doing these questions and then what do you call we'll start the discussion that in like few minutes. Once you're done with this question, raise your hands over. In library. I'm in a library. I'm in the office. No. Anyway, start doing this question. Once you're done, raise your hands over. Yeah, yeah. Those who done with the question, raise a hand. So sorry on the gap. Let's start with no hands open. Yes, hello. I don't like to raise a hand like raise. And MAK did not do STA. Oh yeah, no, only Vella, only Kolana, she only online as an ST. For Vella also we did the BCD. In Vella did we do ASCII? Vella did we do ASCII? Background change. No, I came for a different location. Came to the office. I think we did only have to BCD. Yes, walaikum salam. You read books? No, no, those are not the books I read. Me and books are having a very bad relationship. So, it's not the books I read. But yes, let's start. Yes, Amar. Okay, let's start. So it's just for the show. That's not my books, man. That's my uncle's books, actually. I'm in his office because people have captured my room. So I came up. Where are you right now? I'm upstairs of my house. Okay, let's start. I didn't even go through the number. Okay, the first question. Which of the following is approximately equivalent to 1 TB? Ah, wait, let me first of all take the writing book so that I can scribble there. What is better, Amara? This or the previous one? 2027 writing. So that's the question I teach you all. For the people online, I have done, but well, in Corona, I have not done yet. So I'll teach you as well today. Even though we'll be doing that in a class. Yes, Rushta. Okay. So the first question I said, which of the following is approximately equivalent to 1 TB, right? And they have given multiple options here. So first of all, let me write that here. I'm going to write here the first question on the 2016 paper. First question, the fourth question. Exactly, After. So yeah, 1 TB. And the options they have given here are they want to find out is it equal to 1 times 10 to the power 6 MB. So options we have are 1 times 10 to the power 6 MB. Next, 1 times 10 to the power 6 GB, KB, and bytes. GB, KB, and bytes. Is all three the same value? Like all two of them, both of them are 10 to the power 6 and 10 to the power 6, 10 to the power 9. 10 to the power 6, 10 to the power 9. Okay. Now, when you're doing the conversion, I told you, first of all, you should know the units. Okay. So to know the units, I told you all a stupid way to remember. Do you all remember that stupid way? I said big brother can mate green blue. Yes, the big brother method, purple. So these are the measuring units. Good job. You'll have some brains that can recall stuffs. Now, the given answer, they have given that value in TB and they're asking you to find the correct value now. So let's go one by one. First of all, go through the answers given and tell me what is the one that's more closer to TB. It can be up or down, that's not an issue, but who is more closer to TB? Correct. Out of the given values, the most closest value for the TB value is the GB value. Okay. So I told you all to remember this as like going up and going down in a company. No? So in a company, if you're going down, sorry, if you're going up, then your position increases and your salary gets multiplied, right? Same thing here as well. If you're going up, you're going to multiply. I told you normally what we do is we multiply by 1024. Normal situation, we multiply by 1024. But if you can remember, a similar question like this we had in the paper class, I think last class or week before the last. And there also we had this word called approximately equivalent. So I told you when it's approximately, when I use a word called approximately equal, then what do we do? Instead of taking 1024, what do we do? I told without taking 1024, that's different amount we take, then it's approximate. How much? Perfect. When they use the word called approximately equal, keep in your mind, we're going to use the amount as 1000 instead. Okay. So to convert from TB to GB to multiply by 1000. So if I take 1 TB to convert it to GB, I'm going to multiply it by 1000. So I can represent 1000 as 10 to the power 3. So if I come and see, is the GB answer correct? No, they have mentioned GB answer is 10 to the power 6 GB. So therefore, this answer is wrong. Now, if I cut off GB, what's the next closest I have? Given answer. Perfect. The next given answers, next closest I have is the MB answer. So let's convert MB and see is the answer in MB correct. Now I already have the value in GB. See, I have the value in GB as 1 times 10 to the power 3 GB. So what I'm going to do is I'm going to convert this GB value to MB. Again, we're going one step up. To go one step up, we multiply by 1000. Okay, so the amount on GB we have is 1 to the power 1 times 10 to the power 3. This amount we multiply by 1000 to get the answer in MB. So 10 to the power 3, 1000 can be represented as 10 to the power 3. And I have told you earlier as well, in multiply, when you have two same numbers and it's multiplying, then what we can do is we can add the index. So if we add the both index, what will we have here? 10 to the power? Okay, Amana. If you want, you can bring it to the class today as well. Perfect. That's going to be 10 to the power 6. So if you go and see the MB answer matching, they have mentioned 1 times 10 to the power 6 MB. Yes, that answer is matching. So this is the correct answer. So if you, for the first question, if you had mentioned the answer as 1 times 10 to the power 6 MB, mark it correct and put 1 mark there. Okay, perfect. Then second question, what is the decimal equivalent to the octal number 64? Again, if you have any questions, drop in the chat. So octal number 64. Should I do it in the tute? Yes. Those who have the tute, you have to do it in the tute because these are the questions that's there in the back of the tute. So 64 is an octal number. Then. What is the decimal equivalent to octal number 64? So they ask me to convert this to decimal. To convert from number system to decimal number system, the method is same. What you should do is multiply each digit by its place value. So 6 is one digit, 4 is one digit. I have to multiply each digit by its place value. So first of all, let me figure out the place value, right? To figure out the place value, you need two datas. First is you need to know what is the base of that number. Second is the position. Always keep in mind the position starts from 0. So I start with 0 here and keep on increasing and I go towards my left hand side. So this one's place value will be 8 to the power 0. This one's place value will be 8 to the power 1. It keeps on going like that. So what I mentioned here is to get the place value, I need two datas. That is the base of the number system. And then here I have the position. So anything to the power 0 is equal to 1. 8 to the power 1 is equal to 8. So what I have derived here is basically, I have derived the respective numbers, place, value. Okay, the respective numbers, place value. Then what we do is we multiply every digit by its place value. So if I multiply 1 times 4, answer is 1 times 4 is 4. If I multiply 8 times 6, 8, 16, 24, answer is 48. So first step, multiply every digit by its place value. Second step is add them together. So answer is 48 plus 4 which is 50. So if you go to the answers here, the correct answer is option number. Got it correct, mark it correct. One mark there. If you have any questions, drop in the chat. What tute is this? Third lesson tute. Last few pages, you might notice it. If you have any questions, drop in the chat. Huh? Then question number 33. In the ASCII code, the character Q is represented as 1010001. Right here. It's question number 5. This one is 33. Question number 33. In that they are saying the ASCII value for the letter Q is equivalent to 1010001. 1010001 base 2. And they're asking you what is the option that represents the word called put in binary form. Okay. If you take ASCII, ASCII is a coding system, right? Which is used, which we used to use earlier to represent characters in the computer. Now, if you want to represent numbers in the computer, we know we have this decimal, binary, all these stuffs. So a normal number we can convert to binary and represent. But if you take letters, by default, a letter doesn't have a numerical value. If I tell A, B, C, D, E, F, G, this doesn't have a numerical value. So ASCII is a coding system that gave a numerical value for every character. Okay. So there is a whole table consisting 128 different characters and the respective value, which the ASCII has already defined. Okay. So if you're going to by heart all those 128 characters, it's difficult. So mostly in questions, they'll give you a hint. Okay. Now here they are given you the value of Q in binary. Actually, if we find the value of Q in decimal, our work will be easy. So first step, what I'm going to do is I'm going to convert this number to decimal first. Okay, first step, what I'm going to do is I'm going to convert this number to decimal. To convert any number to decimal, I told you to multiply each digit by its place value. No? So if I multiply each digit by its place value, and if I add them together, the answer I'll be getting here is 64 plus 16 is 70, 80, 81. I'll be getting the answer 81. Do you all want me to show the workings? You want the workings? I can show you all the workings to find 81. Okay, some of you want the working, I'll just show you. So if I'm going to show the working, it would look like this. Just write every digit. 10000. Below every digit, write the place value. Two to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6. So this number is a binary number now. So I wrote the place value. The previous question had octal number, so I wrote octal's place value. Is 1010 blah blah. That's a binary number. So I wrote binary's place value. It is 2 to the power 0 is 1, 2 to the power 1 is 2. So I'm writing all the digits place value. Okay. Then what you do is you multiply every digit by its place value. When you multiply every digit by its place value, 64 times 1 is 64. 32 times 0 is 0. 16 times 1 is 16. 8 times 0 is 0. 4 times 0 is 0. 2 times 0 is 0. 1 times 1 is 1. So you multiply every digit by its place value and then you add them together. So I'm going to ignore the 0 and add only the whole numbers which are greater than 0. So 64 plus 16 is 70, 80. Answer is 81. So this is how I found out the decimal value for Q is 81. Is that part clear? Priya, forgot it now? How I got the 81? Okay. Sorry. So now after I get the decimal value, if you look at the what you call ASCII table, how ASCII works is they have given the value in a sequential order, which means let's say if A is equal to 65, okay, then the value of capital B will be equal to 66. C will be equal to 67. It's then a sequential order. When the number increases here, the letter also keeps on increasing. So now We know the value of Q. We know Q is 81. We have to figure out, first of all, what is the decimal value for P. Okay, we have to figure out what is the decimal value for P, what is the decimal value for U, and what is the decimal value for T. Now, we know that Q is equal to 81. So if you look at the alphabet, this is how the alphabet is done: P, Q, R, S, T, U. This is how the alphabet is. So now tell me, if Q is equal to 81, what do you think the value of P is going to be? Again, these are then a sequential order. Perfect. P is going to be equal to 80. And then how much is U going to be? Correct. If it's 80, 81, 82, 83, 84, 85. U is going to be 85. And T is going to be? T is going to be? Perfect. T is going to be 84. So now using this, I first of all found the value of Q from the question. And with the help of Q, I figure out the value of P and the value of U and the value of T. Okay. So that's the second step I should do. So first step, I'm finding the decimal value for Q. Second step, find the decimal value for the remaining numbers we need. Is this part clear, all of you? Okay. So the next step we have, if you have any questions, Dr. Chatta, the next step we have is we have to convert them to binary. We have to convert them to binary. Now, the normal usual method you all might convert to binaries, you all might use a division method. No? For example, you might take a number like this. You might divide it by 2. So 2 times 40 is 80. 0 remains. Again, divide this by 2. 2 times 20 is 40. 0 remains. Again, divide this by 2. 2 times 10 is 20. 0 remains. Divide this by 2. 2 times 5 is 10. 0 remains. Divide by 2. 2 times 2 is 4. 1 remains. Divide by 2. 2 times 1 is 2. 0 remains. Divide by 2. 2 times 0 is 0. 1 remains. So you all might do a division like this, and then you might get the remainders from bottom to top. And normally you might find the binary answer for 8. Yes, let's say 1, 0, 1. 1, 2, 3, 4. 4 ones, 4 zeros. This is how normally you all might do the question. But there's another shortcut as well, which I taught in the class. I'll use that question here. Yes, Krishna. The MCQ. I mean, how can you show the method? It's literally an MCQ. Do you give a method for MCQ papers? No, right? So what do you call there's another shorter method. Normally, if you take ASCII, always ASCII, what happens is it will represent every character using 7 bits, meaning 7 binary digits. That's how ASCII's rule is. Always we have 7 bits. So what you can do is you can write the first 7 bits place value. Okay, if there are 7 binary digits, 7 binary digits place value, just write it there. So that's going to be the first 7 bits place value is 1, 2, 4, 8, 16, 32, 64. These are the first 7 bits place value. Okay. And then second step, what you're going to do is you're going to figure out to form the respective value, meaning to form the number 80 out of these, what are the numbers I'm going to enter. Okay. So look at the numbers and tell me if I want to get the number 80 out of the given numbers, what are the numbers I should use? Like out of 64, 32, 16, 8, 4, 2, 1, out of these numbers, if I want to form the number 80, then what are the numbers I have to add together? As usual, Hafsa, you know my answer. Correct. 64 plus 16. 64 plus 6 is 70. 70 plus 1 is 80. Yes. Just 64 plus 16, right? So below the numbers you need, write 1. Below the numbers you don't need, write 0. So basically, if I convert 80 to binary, my answer will be 101 and 4 zeros. See, did we get the same answer here? 101, 4 zeros? Yeah. See the same answer we got here, 101, 4 zeros. Okay, to form the number 80, I need 64 plus 16. Now, just like that, tell me, to form the number 85, what are the numbers I have added here? Out of the given numbers, what are the numbers I have to get 85? 64 plus 16 is going to give you 80, right? So what else you need to get 85? Perfect. You need 64 plus 16 will give you 80. And to make it 85, we need the addition of 4 and 1 as well. So below the numbers we need, we write 1. Below the numbers we don't need, we write 0. And our final answer is going to be 101, 01, 01. Similarly, tell me, to form the number 84, what are the numbers I will need? Out of these 64, 32, 16, 84, 21. Exactly, exactly. What are the numbers I need to form the number 84? Perfect. Form the number 84. We need 64, 16, and then 4. So below the numbers I need, I wrote 1. Below the numbers I don't need, I'm writing 0 here. So my final answer is 84 is equal to 101, 01, 00. Is this part clear, all of you? I found all the binary values equivalent to 80, 85, 84. What is the number? This is MCQ, Amara. There is no, you don't have to show methods. But yeah, if you have a like a part 2 question, they ask the method, yes, this is acceptable. Next, if you take ASCII, the main part of ASCII is you put these binaries together. Okay, so for example, the word PUT in ASCII, it will be equivalent to, have they kept space in the answer? Okay, the answers they have kept space, but normally we write the whole thing is as one word. We don't keep space normally, but yeah. So for PUT, first of all, I need P is binary value. That's basically 101 and 4 zeros. And then I need use value, that's 101, 0101. And then T's value, which is 101, 0100. Understandable as well. I always would make sure that should be 7 bits, 7 bits, 7 bits. Accountancy, the number of bits matching, you're good to go. Easy, easy. No, it's accepted, Amara. No issues. So if you go to the answers here, 101 zeros. 101 zeros, 3 of the correct. 101 zeros, correct. 101 zeros, no, it's wrong. 101 zeros, wrong. So now we know answer 1 and 3 has 101 zeros. So let's check the second value. Second value should be 101 0101. 101 0101, correct. 10101, wrong. So if you go through the answers, the answer that has a correct answer is the first one. Why, Amara? Yeah, I am lazy. That's not so much. That's so little. That's actually just a part of the whole thing. There are more stuff which I have shown here. Subject Amara. Yeah, yeah. So, I did touch the bits. Next. If you have any question, double chat. Huh? Consider the following four numbers presented in different number system. Which the following statement is true regarding the above four numbers. Okay, let's see. They are, if you look at the answers here, they are comparing the numbers and seeing which number is larger, which number is small, and all those stuffs. If you want to compare numbers like that to see which number is larger, which number is small, all those stuff, all of them have to be the same number system. Okay. So tell me, what is a suitable number system? We can keep all these numbers in order to compare them. Like what is a common number system? We can make sure all of them are to compare. Is it Amar? Like, correct. It's the decimal. So if I convert, so 243 is order in decimal. If I convert the remaining answers decimal, I showed you earlier how to convert decimal. To convert decimal, you just have to multiply each digit by its place value. So if you convert decimal, this will be equivalent to 3 plus 8, 16, 24, 48 plus 512 into 3. 512 into 3 is equal to 1024, 1524, and 1536. Sorry, 64. No? 64 times 3, not 2, 3. 64 times 3 is basically equivalent to 1000, not 1000, what do you call 190. So 3, 4, 5, 5 plus 8 is the. So if you all convert 363 to decimal, you'll get 245. Then the decimal answer they are directly given you as 243. If you convert the F3 base 16, if you convert this to what do you call decimal, you'll be getting 3 plus 16 times 15. 16 times 15 is I think 255. That's basically 160 plus 80, 140. So answer is 243. And then there is binary number. I'm here doing mind calculation, but you all have to do this method. Multiply each digit by its place value. So this number, if I convert to binary, I'll be getting 1, 2, 4, 8. 4, 8 is 12. 8, 9, 10, 11. So 1, 2, 4, 8, 12, 16, 21, 2, 4, 8, 16, 32, 64, 128, 256, 55, 5 minus 2 is 3, 5 minus 1 is 4, 243. So the binary number, if you convert to decimal, you will be getting 243. First of all, tell me, those who did this question, are these the binary decimal numbers you all also got? Like F3 is 243, 363 is 245, this is 243, and this is 243. Are these the values you all got? Can you recheck the octal thing? 363. That's 1, 8, 64. 1 times 3 is 3. 8 times 3, 8, 16, 24. 48. 64 times 3, 4 times 3 is 12. 1 remain. 6, 12, 18. 9, 1, 9, 2. So 3, 8, 9, 10. 8, 9, 10. 13, 1 remains. So 9, 13 plus 1, 14. 1 remains. Yeah, 2, 4, 3. Octal is 2, 4. Is octal 2, 4, 3? Wait. Yeah, octal should be 2, 4, 3. Not 2, 4, 5. How others also correct? That means others have got the octal number wrong there. Yes, not no, next after that. I think week after that most of them are. Okay, perfect. Why, sir? Yeah, why? Okay, perfect. I thought my answer is wrong. Ah, that's fine because that's why I double check. I told you because I'm doing the mind calculation, my answer can be wrong. I ask will verify, that's fine. Okay, next. The spreadsheet one I said I'll do it in the grade 11 class, so yeah. Okay, that's it. Last week why didn't we do it? Ah, we did a database question, no? Yeah. So now let's answer the question. Huh? The first question they're saying F3 base 16, that is this fellow, is larger than the other three numbers. Is that statement correct? Is it larger? Is it Zaki? No, so that's wrong. Second question they're saying 363 base 8 is smaller than the other three numbers. Is this number smaller than the other numbers? No, all of them actually equal. So that's also wrong. Third one, they're saying four numbers are equal to each other. Are they equal? Yes. Four numbers are not equal. Are they not equal? No. So the answer is going to be the answer number three. You got any questions? Drop in chat. First of all, tell me out of 4 marks, how many marks you all got here correct in the 2016 paper? Suraya, probably she might be sleeping. I'm wondering where the hell she is. Good job. I'm answering your question. Which you asked earlier. Right? As usual, Amara. This is not the time they are away. The time they are asleep. Okay, next question. Always sleeping. So if you're coming in at the time they're sleeping, what can I do? Left your kids in your home. No? It's downstairs, man. I just climbed the stairs and came up. And you think there's no people? Question number one. Can't digest the truth. What to do? Sad life. That's why they say, "Umma kasakatam sayam." Which of the following decimal numbers is equivalent to the binary number 01011? Is it? Okay, so the value is equal to basically 1, 2, 4. By the way, if you're wondering what is the short method I convert binary to decimal, if you look at this binary number, it looks like this, right? 1011. Okay. So if you all can remember, I told a long time back, just write the place value. And one method you can do is wherever zero is there, cut the place value, write the sum of the remaining. So if you cut the remaining here, 8 plus 2 plus 1, that's going to give you 11. That's one method you have. But the other method, what I do is sometimes, like what for the previous question, for this question, when I wanted to convert to binary, the method I applied was not this. Yeah, what I did is, so I took this number, I just removed the left side zero because that doesn't make a difference. So you take the binary number, okay, you write the place values, that's 1, 2, 4, 8. Now what you do is, normally in binary, if all the digits are 1, meaning if I had a number like this, let's say, okay, if I had a number like this where all the digits are 1, then if I want to convert this to decimal, the value of this number will be always equal to, if I write their place values, and if I write all the place values, the next place values are right. that next place value minus 1. So for example, if I go in this series of numbers, after 16, what's the next place value we have? Perfect. After 16, the next place value you have is 32. So actually, if I add all these together, the addition of these will be equal to 32 minus 1, which is 31. So that method only I am going to apply here as well. If I add all these together, it will be equal to the next place value minus 1. So next place value is equal to 16. 16 minus 1 is equal to 15. So 15 will be the answer if all of them are 1. Now I know this fellow is not 1. So what I'm going to do is I'm going to reduce that from here. That's basically 15 minus 4. I have the answer is the 1. So depending on the question you can decide whether you're going to use this method or this method. This is a method that's taught in syllabus. Okay, the first one is a method that's taught in syllabus, which I've cut certain steps. Second is something that's not there in syllabus, but you'll get the marks. Okay, so now for this question, because numbers are too long, you have too many numbers, I applied actually the second method only. That's why you might have noticed here, when I was doing this mind calculation, I did some subtraction here. I did not do any additions here. So we got 11, mark it correct. Any questions? Drop the chat. Is that your home? The background is looking so much interesting that one means. It's my home, but not my room. It's the office room and not mine. Exactly, Hafna. That's the power. I don't read books. Next. I had a question to the chat. Ta-dun, 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 ta-dun. Which of the following octal number is equivalent to the binary number, blah, 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 blah. Okay. You know to convert from octal to binary, we group these numbers, right? So these three numbers will be one set. These three numbers will be one set. These three numbers will be in one set. And these three numbers will be one set. Okay. That's how we convert from octal to so binary to octal. So let me just rewrite this in the next page so it's very clear. How many ones we have? 1, 2, 3, 4, 5. 5 ones. 2017 all over paper. We have 5 ones. 1, 2, 3, 4, 5. 0, double 1, double 0. 0, double 1, double 0, 1, 0. So if I convert them, if I group them, these 3 bits will be in one set. These 3 bits will be another set. These 3 bits will be another set. So we have 4 different sets. If I want to take this set separately, the sets I will be having are we always start the separation on the right side. Huh? The sets I'll be having one is triple one, another one is double 1 0, the other one is again double 1 0, and the other one is 0 1 0. So now what you're going to do is you're going to consider each of them as separate numbers. These are 4. You got to consider them as 4 different binary numbers and write their place value below it. So just write the place value. Wherever 0 is there, cut the place value and write the sum of the remaining. Here 2 is remaining. Here 4 plus 2, 6 is remaining. Here 4 plus 2, 6 is remaining. Here 4 plus 2 plus 1, 7 is remaining. So now we just join them together. The final answer is going to be equivalent to 7662 base 8. Are those reading books like fictions and unfictions? These are all unfictions. Wait. Is fiction storybooks and unfiction storybooks? So your answer is 7662. Any questions anyone have here? Have any questions? Drop in the chat. Do you have goosebumps? Why? What? Is not mine. Well, the 48 laws of power. You want to learn laws of power? Actually, the room I'm captured today is actually an author's room. Either the person who owns the room is an author. He has a book written by himself as well. These are books he wrote by himself. So you can buy copies of books here. It's called Road to Billionaire. You can buy and become a billionaire. I don't know. Have you read those books? I read one book. From here, when I was in school time, I think this is around grade 8 or grade 9, I guess. I read one book and I can't remember the name of the book. That one book, I read, I think, two chapters. And I prepared a speech based on that book. And I went and gave it in front of the stage in my school. That's the impact of that one book. I started the speech itself with a quote. I still can remember that speech. It started by saying, I think the speech started by saying something like, even if you're a street sweeper, you have to sweep the street like no one else, something that I can't remember the exact wordings. But the idea was, I can remember it was saying something like, even if you're a street sweeper, you make sure you sweep the street such that no one could sweep like you, or it's like perfect. I can't remember exactly. And I kept on going, I can't remember it. I find the speech as well. Just only one book, two chapters. I'm wondering how much of books. Yeah, there's several books. I am lazy to read. I don't know how even I read that book that day. But using that one book I read, I went and gave a speech in the stage in front of hundreds of people. 123 triple one 01 Lyceum 011 000 I love power. That actually, yeah, they're power because my style of giving speed is completely different. I don't go in front of the what you call stage and I'll be like, good morning, good evening. I don't even greet people. Directly, I actually greet in the middle of the speech. I start the speech with a quote. So I went to the stage, took the mic, and directly shouted at them. They're like, if you're a street sweeper, it makes you street the sweep. Up the answer, I can't remember. I just know that if you're a street, that's how I started. But to the school you started. I went to Lyceum. So 111 010. Okay. In the second question, they've asked you to convert this to hexadecimal. Now, if take binary is where we break the whole. Sorry, octal is where we break the whole binary number to 3 bits by 3 bits. Hexa is where we break the whole binary into 4 bits by 4 bits. So these 4 bits are one set. 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 So when you don't have a complete set, you can add 3 zeros in front to make it a complete set. So the sets I have here are these 4 bits one set, these 4 bits one set, these 4 bits one set, 1, 2, 3 for these 4 bits one set. So the sets I have here are one is yes, 0001, and the other set is 1101, and the other set is 0 1 1 0, and the other set is 00 1 1, and the other set is 10 10. Now, just like how you did for previous method only, here also what we're going to do is we're going to consider each of them as different binary numbers, and below every digit write their respective place value. So 2 to the power 0, 2 to the power 1, 2 to the power 2 here. I'm going to write their respective place value 1248, 1248, 1248, 1248. Wherever 0 is there, cut the place value and write the sum of the remaining. So 8 plus 2 is 10. Here 2 plus 1 is 3. Here 4 plus 2 is 6. Here 8 plus 4 plus 1 is 13. And here we have 1. Okay. Nice. Is there a video? This happened several years back when. No, I don't think I have. Exactly. Except like somebody that went to school. I have not gone to much school, so I don't know that. Yeah, no, so you can go and give a speech. Why is it? Let me write 10 as a here. That's where I'm going to come to. You don't normally read. Yeah, I don't normally read. Do we have notes for vendor of sweets? Nope. You mean jargon, Mali? That story, right? You get so much points in competitions then. And yeah. Okay. Now, when you take hexadecimal, the idea of hexadecimal is representing 4 bits as one digit, okay, or 4 bits as one character. Now, if I look at here, do I have 4 bits as one character? Yes. If I look at this as well, do I have 4 bits as one character? Yes. If I use look at this also, yes. So these three that I have underlined, I have 4 bits representing as one character. But if I look at this fellow and this fellow, is 4 bits representing one character means no. Okay. So in hexadecimal number system, whenever what do you call you want to represent 4 bits as one character, whenever you have a situation of representing 4 bits as one character, 4 bits as one character, in those situations, what happens is if you don't have one character, we use a letter to represent that. So the first 2 digit number we get is A. So the first 2 digit number we get is 10. So 10 is represented using A. Then 11 is represented using B. And 12 is represented using C. And 13 is represented using D. 14 is represented using E. And 15 is represented using F. So these are the hexadecimal numbers. So based on that, I can tell 10 is basically equivalent to A. 13 is equivalent to D. And now I can just join all these digits together and write my final answer as 1D63A base 16. So 1D63A base 16. That's the option number 2. We got it correct, mark it correct. 1 mark there. If you have any questions, drop in the chat. I don't know, Rihan, because I don't read. Who's that, your brother? Oh, my uncle. There is, when I was a kid, until grade 6, Rustam. Rehan, I don't know. Why is Zaki? Why? Have you read Sherlock Holmes? I think I have read Sherlock Holmes in school, but not in reality. Why is Zaki? Why? Okay, next. I have not heard. हमारा है I still don't know what is the story of Harry Potter. I have not seen Harry Potter. I have not read Harry Potter. For your information. I just have seen a picture of Harry Potter, but I don't know even there. Yes. I have seen small scenes they might show during this what do you call this season, during those holiday season, but I haven't seen. Except me, I'm not at the. It's not boy, it's the Unmei. Unmei. When it the following statements, which the following are true? Okay. 40, let's see, I'll come with the second one because second one is easy. 43 base 10 is equivalent to blah, 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 blah. Let's see, is it equal? If you convert this to binary, so decimal, you get 1, 2, 4, 8, 16, 32, 64, 63, minus 20, 63, 53, 43. This is correct. So if you convert, you'll be figuring out the second answer is correct. Then third one, is this equivalent to 8? In octal, this is equivalent to 3, is equivalent to 5, 53. That's also correct. Okay, B and C are correct. Okay, I have to check A. I thought I can skip this question. I can find the answer by this, but no. So B and C are correct. Because if you take the number 101, 011, and if you convert it to decimal, you'll be getting 43. You can choose one of the methods I showed you all here. Both are correct, huh? I actually did this question in the second method. And if you convert the number 53 base 8, so if you take 101, 011, if you convert this to octal, put 124, 124, wherever 0 is there, cut the place value, where the sum of the remaining, here also will be the answer is 53 base 8. So that's also correct. The 2b base 16. Let's see. Both methods are same. Same but different. Tell me, from hexadecimal, can we directly convert to octal? Yes or no? No. From hexadecimal, we can't directly convert to octal. So we have two methods. One is we can convert to binary, and one is we can convert to decimal. What is easy, binary or decimal? Perfect. Converting this number to binary and then converting the binary answer to octal is actually easy. So let's follow that method. So if I take 2b base 16, so how you convert these two binaries? First, we take both the numbers separately. In hexadecimal, what happens? In 16 is representing hexadecimal number system now. In hexadecimal, one character is representing 4 bits. To find what the 4 bits are, we write the first 4 bits place value. So 1 to 4, 1 to 4. You keep on writing. In hexadecimal, b is equal to 11. So now after you row the 4 bits in below the respective digit, you're going to see form the respective number. What are the digits you're at? To form 2, we need only 2. To form 11, we need 8 plus 2 plus 1. Below the numbers, you need write 1. Below the numbers, you don't need, you write 0. And the answer is going to be equivalent to 0010 1011 base 2. Okay. So this is the octal hex binary answer. So now we're done with this step. Second step is convert that to binary. So we have the number has 0010. You can ignore the zeros in front if you want. 1011. So when you convert this to octal, octal is where we group 3 bits as one character. So these 3 bits are 1, these 3 bits are 1. You can remove the zeros because it's alone. So below every number, I'm going to write the place value, which is 1, 2, 4, 1, 2, 4. Wherever 0 is there, cut the place value by the sum of the remaining. Here 2 plus 1 is 3. Here 4 plus 1 is 5. So answer is 53 base 8. So yes, that's also correct. So answer is the fourth one, all ABC. By the way, A, B, C are equivalent to each other. Is it equivalent? So we have 53 base 8 here. 101, 011, correct? 101, 011. Yeah, correct. Actually, we didn't be okay. I did something stupid. I don't need to do this step. The step that I did here, which I did here is two steps, is actually something stupid. Because why I'm saying that is in the question, if I want to convert from 53 to hexa, okay, I know how to convert that to octal now first. So I have to convert that binary now. If I know that C is correct, then I can directly use this binary number and convert this binary number to hexa. And have to again find that binary number. Why didn't I think of that until I did the question? Anyways, put 1 mark there. Put 1 mark each and tell me out of 4 marks, how many marks I got. If we take this much time for MCQs for the part 2 paper, how can we manage that? I showed you all here step by step, Porumaya. If I'm going to do this question fast, it doesn't take this much time. Because you don't have to show all the steps. MCQs doesn't require steps. So you can omit certain steps and you can do it fast. You don't have to do it neatly as well. So you're doing it actually alone, you can do it faster. Like if you like try doing this question before we start the class, you notice how fast you can do these questions. Wait a minute, questions like these have equal answers if they're all correct. No. I said what happened here is the same 53 is used in this question as here as well, here as well. So what I said was you can't convert 53 to hexa directly. Okay. You want to convert from octal and hexa, you want to convert between them. You first of all convert to binary. Okay. So what I was saying was the question had already mentioned the word 53 here. That same number that was used here as well. And we know that we already found out that the statement is correct. So that means I already know the binary. I unwantedly spend time to find the binary while I already know the binary. That's what I was saying. It is more than enough, Afsa. Ask the people who went and did the oral papers by city. They'll be like 1 hour they were just sleeping in the paper. You can do it fast with practice. Okay, next. I'll give you around 5 minutes. Start doing this question. Enjoy this. I want to do a seminar before your exams. I'll figure out and tell you. It'll be probably a Sunday. Tell you. I'm going to put your hands down. So once you're done with the question, raise your hands over. Don't worry, with practice, you will be able to do these questions also very fast. Start doing the questions, all of you. Those who have doubts, drop in the chat. I'm here only, so if you have doubt, drop in the chat. If you're done with the question, raise your hands up. Hafiz, take a screenshot of this. Done. I will, but not now, Rustam. Before that, there's more important stuff to do. Okay, your time is up. Those are the hands up. Oh, none of you are done. Let's check your answers now. Dun, 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 dun. Yeah, timer. Yeah. In which form is data and instructions stored in the computer? It's very easy answer. What's the answer? Data and instructions are stored in the computer in the form of. Taking time to answer that. It's an easy question. Next. Which the following is the octal equivalent for the decimal number 156? So 156 to convert to octal. From decimal to any other number system, we divide by the respective number system's base. So decimal to binary divide by binary's base, decimal to octal divide by octal's base. So here we are divided by octal's base. 8 times 1 is 8, 7 remains 76. 8 times 8 is 64. 8 times 9 is 64. 72. So 72, 4 remains. Then divide by 8. 8 times 2 is 16, 17, 18, 19. 3 remains. Divide by 8. 8 times 0 is 0, 2 remains. So you keep on dividing by 8 until you get 0 as the 0 as the answer. Okay, so you divide the number by 8, write the whole number value here and the remainder in front. Whole number, remainder, whole number, remainder. Then you join these numbers from bottom to top. So answer is going to be 2, 3, 4, base 8. That's the second answer. You got it correct, mark it correct, put 1 mark there. Next. Which of the following is the binary equivalent for the hexadecimal 2b base 16? The same question was there here actually. So from here, so you can steal the answer if you're a lazy person. But yeah, if I will show the method, hexadecimal is where each character is represented by 4 bits. B is equal to 11. To find what those 4 bits are, write the first 4 bits place value and circle the numbers you need to form the respective digit. So to form 2, you need only 2. To form 11, 11, you need 8 plus 2 plus 1. So below the numbers you need, write 1. Below the numbers you don't need, you write 0. So final answer is going to be something like 0010 1011. Normally, when there is 0 on the left hand side, you can ignore it. So you can write that as 101 011 base 2. Okay, the question is given with the 0. So 0010 001. Yes, answer is the first one. You got it correct, mark it correct, put 1 mark there. Next, if you have any questions, drop in the chat. Which of the following list blah 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 in the ascending order? So ascending is what? Small to big or big to small? Correct. Ascending order is basically where we have numbers from small to big. So if we have to, again, if you want to compare numbers, the easiest way is make sure all of them are in decimal. So if I convert 113 to decimal, I'll get 3 plus 8 plus 64. That's 72, 75. If I convert 1a, I'll be getting 10 plus 16 times 1 is 16. That's 26. If I convert this binary number to decimal, I'll be getting 1, 2, 4, 8, 16, 32, 64. 128, 256. 64, 68, 69, 70, 102. That's 155, 155, 153. Tell me, first of all, are these the decimal numbers you all got? The binary number is 153, octal number is 75, hexadecimal number is 26. Is this the answer you all got? Okay, perfect. So what you're supposed to do is you're supposed to make sure you convert all of them to decimal. Then only you're going to compare. So ascending order means small one should come first. The small one we have is 26. So 1a base 16 should come first. So this is wrong, it's wrong, it's wrong. Directly you have the answer here. Okay. The reason I found 2, and 3 is wrong is because that is not the first answer given. Have any questions? Drop in the chat. We're going for the next one. Which of the following number system is a number 800 is a valid number? Okay. Now to form the number 800, we are taking three digits. We are taking the 0, 0, and 8. Okay. So in decimal, can you represent 800? Yes. In hexadecimal, can you represent 800? Again, yes. But if you take octal, tell me in octal, what are the allowed digits? If you want to form an octal number, what are the digits you could use to form an octal number? Perfect. If you want to form an octal number, the allowed digits you have are numbers from 0 to 7. Okay. So octal you can't represent. Octal you can't represent. Okay. Decimal can. Now, when you compare the first answer and second answer, first answer is saying decimal only, second answer is saying decimal and hexadecimal. So tell me, what is correct? Is it only decimal you can represent 800 or decimal and hexa both? First or second? Exactly. Second is the correct answer because hexa also you can use. Hexa you can use numbers from. If you take octal, it's just 0 to 7. Decimal, we have 0 to 9. But if you take hexadecimal, we have 0 to 9. And apart from that, we have also letters from A to F. And binary, we have only two characters, which is 0 and 1. So in a forming the number in binary, you can use only these two characters. In decimal, you can use any characters from 0 to 9. Octal, any of these. Hex, any of these. Okay. So that's the answer. Okay. Put 1 mark each and tell me out of 5 marks, how many marks you got here of them. We're done, Ashkur. Okay, perfect. Okay, so for today we're done with that. If you have any questions, you can stay and ask. Next week also we're going to do these number conversions only. Basically, if those are coming from my class, it's there in the back of your tute, these questions. Outside, I'll share this part of the PDF in the group. Okay. So those are not there in the group, make sure they're in the group. No, it's from 5 to 6:30. So they're not in the group, I'll share the link. Click on that. Not tomorrow, but next week. Can you explain the logic gates and the truth table? I'll do that. We are starting logic gates anyways next week. Not coming week. Next week we are starting. Walaikum salam. Same to you, Kanika. Sending the PDF and printing? That's weird. Level. So yeah. Okay, that was a good question. So I want a hard question. Bad life. Okay, Zaki. If you want, I'll do it now then wait. Yeah, avasara. Dun, dun. Wait, you sent another question? Which one do you want? The spreadsheet one or the spreadsheet one? Did I discuss? Oh yeah, spreadsheet one I already discussed. You have the this. I was thinking of this one spreadsheet question you were talking about. Sorry, sorry. You're talking about the HDLC question. I will discuss it. Sad like that. Question is talking. Basically, I'm answering the doubts you're bringing. So yeah, there's a doubt. So Yasin, let me check. So you're here, right? Yeah. Okay. A small bookshop in Colombo currently maintains all records about book sales, stock levels, and customer orders in manually. As a result, the shop owner frequently faces problems such as incorrect stock calculations and loss of order sales. As a solution, he has assigned a system development team to develop a simple computerized book sales management system. Before starting development, all the requirements have been clearly discussed and finalized with the system development team. Okay, so they are saying before they have started the development, the requirements have already been clearly discussed as well. Fine. Name the most suitable software development model for this system and give one reason why it's suitable. So if you take SDLC model, there are two models. One is a waterfall model, other one is a iterative increment model. Now, in this situation, there is a shop owner and he wants simple computerized book sales management system. So he wants a sales management system. Okay, he wants to manage his sales. Okay, manage his sales means basically managing his what do you call, let's say, like a billing system, right? So whenever he sells a shop, like whenever he's a bookshop, no, whenever he sells some stuff, he want to record that. Okay, okay. So I answer back, like. What did you say? Rushta, I asked you to send me those message. No, no, this is grade 11. This is not allowed to grade 10, but the grade 10s, if you all want, you all can stay. It's something allowed to grade 11. Okay, perfect. So what do you call, he wants a system to manage his sales, meaning that whenever he sells something in the bookshop, he wants to record that. Now, in this question, they're asking what is the most suitable software development model? No, you have two answers you can mention, but you get the marks not based on your answer, you get the marks based on the reason. Because the question has said to write the model and give the reason, no. So if your reason is valid, then you get the marks. Like for example, you can mention the answer here as waterfall model as well. Okay. But let's say you mention the answer as waterfall model, then your reason for waterfall model will be as all the requirements are as all the requirements have been clearly and finalized. So this is the reason you might give if you choose waterfall model as your answer. Okay. But without choosing waterfall model, if you use it, say we can say at least a part of the system while it's being, that's not suitable actually, that we can see at least a part of the system because this is just only one portion. The system is not having multiple stuffs. The system is having only one portion, that is to manage sales, meaning cash inflow and outflow, not outflow meaning cash inflow. So therefore, I would say waterfall model is more suitable, but you can mention iterative increment model and give an advantages. So it's not only about the model. Your reason is what makes your answer is more suitable. I'll be like waterfall model with this reason. Is that clear? Surya? Okay, after this, when okay, next. State two advantages of the named model mentioned above. Okay. So in waterfall model, the advantage we have is we have any advantage. There's a lot of disadvantage. So in terms of advantage for waterfall model, what can we write? Iterative increment model means there are several advantages you can mention. Waterfall model doesn't have any advantage. The only advantage is it is suitable for small scale project. So, okay, one answer you can mention is less complex. Less complex because compared to when you compare waterfall model and iterative increment model, there is lots of circulation. Like you go to you might complete the requirement identification stage, designing stage, and all those stuffs, and you might again come and check the requirement. No, so there's a set of rotation happening. But waterfall model, there is no rotation. It's just one single flow. So that's one answer you can mention. It's less complex. Second answer you can mention is you can mention like a fully completed product you can get. That's an answer you can mention, or else you can mention, yeah, you can mention that as an answer. A fully completed system can be obtained at once. User sees the system at the end of the cycle. That's feature. That's why I said in a waterfall model, you can't mean there is no advantage. Can mention Karan, there's nothing big. Let me just Google and see. Clear milestones. So one advantage you can mention is all the requirements are clear in the beginning itself. All requirements are clear in the beginning itself. Now, iterative increment model, we might not know all the requirements in the beginning. Middle, the requirements can come and change. Waterfall is fixed. Got it? Have you clear these two answers? Three answers. Then. Any questions, Surya? Okay, next. Roman number three, state to limitations. In terms of limitations, one of the limitations are like disadvantage or problems. One of the limitations we have is it's not flexible. Meaning in the middle, you can't go and add one more requirements. Waterfall model, if you tell the requirements at the beginning, then you completely continue building like that. You can't keep on changing in the middle. So it's not flexible. Another disadvantage you can mention is what you called it takes time to see at least a part of the system. It takes time to see at least a part of the system. Do we need to get the answers only from the text given? It should be relevant. It should be relevant for the text. If the answer you're mentioning is nothing relevant to this text, then you can't mention it. Next. If the system is given to the bookshop owner by the development team for testing, name this testing method and then state the purpose of this. Okay, what is the name of this testing? It's the last testing we do. What is it? Oh, in testing, there are four testings: unit testing, integration testing, system testing, and the final testing we have is the user acceptance testing. So user acceptance testing is where we give the client or a customer to test the system. So user acceptance testing. And what's the purpose? The purpose is basically to check if the client is satisfied. Okay, to check if the client is satisfied with the system. Or to check if the client is okay with how the system works. That's the idea. Got it? Okay. So the last question, recommend a suitable system deployment method for the bookshop and give one reason. So what's the most suitable deployment method here? What do you mean by pilot? Did they say that we have multiple branches here? We have only a small bookshop. That means we have one shop. Pilot deployment is where you give for a small group of, like if you have several group of people, like there's let's say 5 people. Pilot testing is where without giving all 5 people, you might give only for a selected people, like only 1 or 2 person to use. Okay. So here we are having only one branch, one small shop. So only that one shop is there. So what do you mean by a small group? So pilot testing is wrong here. Okay. What do you mean phase deployment? So phase deployment is suitable only if you have multiple versions. So does the system have multiple, like now if you take WhatsApp, WhatsApp has one phase, like one version of, like one section of WhatsApp is messaging. Other one is calling, other one is status. So phase deployment is like without deploying a full application at once, you might first deploy only the call, then add the status, then add the messaging, like without putting the full application as once, part by part releasing. That's what phase. So phase is also, yes. Direct deployment and parallel is correct, but direct deployment is more suitable because the again it's based on your reasoning, you get the marks. So if you're saying direct deployment, your reason would be something like so that is problem of sales management can be completely optimized. And we can fix all now. He has a we know that he has a problem in having incorrect stock calculations and loss of sales so loss of order records. So we are saying by doing direct deployment, we can solve his problem which he has of having incorrect stock calculations and loss of order records. That's how direct deployment is. If you mention pilot deployment, the only answer would be so that he can use mainly the new system. And suppose if the new system stops working, he can go for the old system. So you can give that reason if you mention pilot, but direct is more suitable. Phase deployment is where now, for example, if you take an application might have, let's say, multiple features. Like let's say WhatsApp has, let's say, call feature, message feature, and status feature. So phase deployment is where without deploying the full app, publish the full application at once because it takes time. We might only publish first of all only the call section. Only one part of the application is published. Then once we are done building the message section, once you're done with the message section, now you might go and add that message section. So this will be version 2 of the application. Then after you will start making the status section. Once you're done with making the status section, you might release that as well. So now in version 3, you will have the full application. So phase deployment is without releasing everything at once, you're releasing them in multiple versions. Version 1 first, after some time you might release version 2 with these two. After some time, the version 3. That's what phase deployment is. Got it? Perfect. So yeah, that's the answer for this. Any question? Barakallah. Why is there anything? Most probably no. I know what's the question you had? Okay. Anyone else have any other questions? Oh, he's back. RGB ASCII, the hexadecimal color conversion. Okay, do it now. So they have mentioned version testing as each stages in the textbook. Yes, sorry. Like version 1, version 2, version 3. Like without releasing it once, you're releasing multiple versions. Okay. So let's say we have a color, right? When you take a RGB color code, normally RGB color code will have three values, something like this. Okay. Always keep in mind there will be three values. Amount of red used, middle value will mention the amount of green used, and the last value will mention. So you can form a color by mixing red, green, and blue. Okay. Now we have mentioned a value here. Right? Each of these values can be a value that is ranging between 0 and 255. This is the range a specific value would be. Okay. So the smallest value we can have is 0, 0, 0. The largest value we can have is 255, 255, 255. Is that part clear, Surya? Sorry, Ira? Perfect. So whenever they want to convert this to hexadecimal color code, always keep in mind in a hexadecimal color code, sorry, always in a hexadecimal color code, we start the color code with hashtag, and then there will be 6 characters: 1, 2, 3, 4, 5, 6. Out of these 6 characters, the first 2 characters will represent the amount of red used. The middle 2 characters will represent the amount of green used. And the last 2 characters will represent the amount of blue used. So if you want to find out these hexadecimal values, what you should do is you have to just convert these numbers that you have here from decimal to hexadecimal. From decimal, you will convert to hexadecimal. Okay. So for example, if I take the number called 235, this number called 235, if I convert hexadecimal, you divide by 16. 16 times 1 is 16. 75. 16 times 5 is 80. 16 times 4. 16 times 4 is 16. 32. 64. 75 is 11. 11 remains. If I divide by 16, 16 times 0 is 0, 14 remains. In hexadecimal, you write the numbers from bottom to top. In hexadecimal, 11 is equal to B and 14 is equal to E. So answer here is going to be EB base 16. Likewise, you're going to convert the remaining two numbers. So if you convert 101 to hexadecimal, divide by 16. 16 times 5 is 80. 16 times 6 is 96. 96, 5 remains. 97, 98, 99, 100, 101. Divide by 16. 16 times 0 is 0. 6 remains. So write the remainders from bottom to top. So answer is going to be equal to 65 base 16. Likewise, you're going to convert the 27 as well. If I convert 27, 16 times 1 is 16. Then how much remains? 61, 16, 4. 4 plus 7, 11 remains. Then divide by 16. 16 times 0 is 0. 1 remains. So 11 is equal to B. Answer is basically 1B base 16. Give me a moment. Give me a moment, guys. I'll give me a minute. I first of all, are you clear about this step? Yeah. So what I've done here is I just converted each of these values to hexa. So after that, you just have to come and replace it here. The 235 in decimal was, so red color in decimal was 235. So red color in hexa is basically EB. So I come and write a EB. Green in decimal was 101 and green in hexa is 65. So I come and write a 65. Blue in decimal is 27. When I convert hexa, it's 1B. So let's say when you convert, you come up with a one digit number. Suppose if the answer is one digit, always make sure you add a zero in front. Okay. Whenever you have one digit number here, make sure a zero in front and keep it always in two digit, two digit, two digit. Two digits for red, two for green, and two for blue. This is the idea of converting from R0 to hexa. Always keep in mind this number is mentioned in decimal. And this number is mentioned in hexadecimal. So you just have to convert from decimal to hexadecimal or else hexadecimal decimal. That's how the conversion happens. Got it? It'll always be a two-digit number. Yes, it'll always be a two-digit number. That's why the largest value is 255. Okay, so if you convert 250, you can see the largest number is 255 now. If you convert 255 to what you call divide by 16, 16 times 50 is 15 is 240, 15 remains. Divide by 16, 16 times 0 is 0, 15 remains. So 15 is equal to F. Write the answers from bottom to top. Answer is FF base 16. So the reason why we had 255 as the largest number is because of this. If you go for 256, then it will become 3 digit. I think 3 digit. 16 times 16 is 26. If you take 3 digit numbers, sorry, if you take numbers more than 256, you can go for a 3 digit, not exact 256, but if you go on increasing 255, it becomes, you can go for 3 digit numbers. That's why you always stop with 255. So when the range is between 0 and 255, you always end up with 2 digit numbers. Clear? Any other questions, Mr. Sorry, Naira? What about ASCII? We did ASCII, weren't you there? Weren't you there when I did this question? Just watch the paper class because I took the today's recording. Just watch the first few parts where we discuss these questions. And then if you have doubt, let me know and I'll clarify it. So, Rushta, let me take your question now. Chup, chup, chup. These are only color conversion in O levels. Yeah. They can do vice versa as well. They can give you the hexadecimal and ask you RGB as well. So the idea is basically decimal hexa conversion. Correct. Okay, Rushta, your question. Which field is more suitable for the primary key in the students table? So students table has four fields. Admission number is one field, name is one field, class is one field, date of birth is another field. So primary key values should always be unique. It can't repeat. So out of the given numbers, given our values, the field that looks unique and will not repeat is admission number field. So answer is going to be the first one because name can repeat, the class can repeat, date of birth also can repeat. Date of birth can repeat if there is twins in the class. If there's twins, both will have the same date of birth now. Correct? Which is the following an example for a foreign key. So foreign key is another table's primary key, right? First of all, you should know primary key, then only foreign key is easy. Now, if you take students table, this is a primary key. And if you take the results table, in the results table, the primary key is index number, result, admission number. So admission number 1, 2, 3, 1, 2, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5. What is index number? Okay, I can't exactly tell what is the primary key in the results table because I don't know what is the meaning of this index number field. Because if it's a subject's index number, it's a different story. 56363 520. Yeah. So I'm not sure exactly of the what is the primary key in the results table, but anyways, that's not a needed data. That's not a needed data. So with the available data, we know that admission number is a primary key here. So always when a primary key is mentioned in another table, it becomes a foreign key. So here, if it's a primary key, if it's mentioned somewhere else, it becomes a foreign key. So do we have this admission number in another table? Do we have the primary key of students table? Do we have it somewhere else? Yes. So when the primary key goes to another table or is mentioned in another table, it becomes a foreign key there. So admission number in result table, that's actually a foreign key. Is that clear? So to find foreign key, first of all, find primary key and see is the primary key mentioned somewhere else. Why can't the first one? So if you are saying this is a foreign key, tell me where is the primary key? For it to be a foreign key here, it has to be a primary key somewhere else. Where is it a primary key? It's going to be foreign key here. In which table is it the primary key? Admission number in students table. Okay, if you're saying it's a primary key here, if you're saying it's a foreign key here, then where is it a primary key? I said no. For a field to be a primary key, it should be a prime. For a field to be a primary key, it should be a foreign key in the table. How do you know this is a primary key? You can't tell it's a primary key without knowing the meaning of the word index number. Now, as far as I can remember, as far as I can understand, index number sounds like the subject's index number. Okay. So if I take subject's index number, right? Let's say 30456 subject, let's say that is maths, and let's say 23436 is HA science. Okay. So the students call 12432 for maths, he has got 165 marks.
But let's say the student call 12432. For science, if I want to show his marks, I'll again repeat that science index number. And I might show his science marks. So we can't guarantee and tell that it's going to be a unique field without knowing what do you mean. Always to find the primary key and foreign key, you should understand the table. Without knowing what the table is meaning, you can't make decisions. You should always know what are we storing in a table. Without knowing what are we storing, you can't figure those out. So to tell is this a primary key here, we don't have enough of data. Yes, Adhika. It's a grade 10 lesson number 9 question. I'll tell you an easy question. Okay. Let's say there's two rooms. You definitely know in this room you have a treasure. In this room, you're not sure. You can have, you cannot have. So here the probability is 100%. Here the probability is 50%. So which room, if you have the chance to choose only one room, which room will you choose? The room A or the room B? There's two rooms. One room, definitely there is a treasure. Other one, 50% probability. Exactly. So if you take this admission number, what do you call admission number being the foreign key here, become a foreign key here, it has to be a primary key somewhere else. Where is the primary key here? Now that is 100% sure. There is no doubts there. There is no confusion there. So that's definitely a primary key. But whether this admission number can be a primary key in the result table, we don't have enough of data. Without knowing the meaning of index number field, we can't, or without knowing what type of data we're storing here, we can't tell it. So therefore, mention that is unwanted. It's unwanted risk because oral exam paper after you wrote, you can't change your marks. After you give the paper, halas, game over. So when you know an answer is 100% correct, go for the 100% correct answer. Again, the reason why I can't tell admission number is a foreign key is I don't know. So I can't tell why admission number is a foreign key here. The reason why I can't tell it's a foreign key here is because I don't exactly know where it's a primary key at. Got it? 100% no, no issues. Next. The number of fields and records of the result table are fields are the number of columns. So we have three fields and records are the rows containing data. So 1, 2, 3, 4. There are four rows containing data. So answer is 3 and 4. Option number 3. Got it? Fields means the number of columns. Like index number is one field, result is one field, admission number is one field. So these are three fields. Record is rows containing data. So we have 1, 2, 3, 4. Is that clear? Any other questions? Okay. Anyone else have any other questions? Okay, so as there's no other questions, I'm going